Hey guys, so today we're going to be talking about tangents and chords, just a little more building off of our circles unit. So let's get right into it. So we define a tangent line is a line that touches a circle only at one point, and that point is called the point of tangency. So let's draw this out. So we have a point of tangency right here. I'm going to label this P for a point of tangency. And so we have our tangent line going through that point of tangency, and that's a line T. And this is circle C with our radius here. Okay, so now we can say that line T is tangent to circle C, and it's tangent at the point of tangency P. So that's how we say that in a formal way. So if you notice, I drew a radius, and then I drew that it is a right angle between the tangent line and our radius. Well, it's important to note that a tangent line is perpendicular to the radius drawn to the point of tangency. So line T is perpendicular to radius CP. So that goes for all points of tangencies and tangent lines. If you draw a radius from the center to the point of tangency and you have that tangent line, those will always be perpendicular. Alright? So now just an important theorem to note is that two-tangent theorem. So two tangents drawn from a common point outside of the circle are congruent. So what this means is that if we had a point right here, and I'll label this point B, and we have point A and point C, and this is circle C. So say we had a line going, or a tangent line going from A to B, and then we also had a tangent line going from C to B. So we have two tangents drawn from a common point outside of the circle. And so automatically, because they have a common point outside of the circle, we can say that AB is congruent to CB. Now I know my drawing's not perfect with drawing through the points, but you get the point. So this is an important theorem to keep in mind. So with our first two, I want us to prove that we have a tangent line. So, and forgive me for my handwriting. So let's look at this first one. So we have number one here. I want to prove that 9.6 is my tangent line. So how would we do this? Well, remember what I said earlier about tangents? Well, if we have the radius and the point of tangency, that line of tangency is going to be perpendicular to the radius. So we should know that this right here is a 90-degree angle. So we can use the Pythagorean theorem to prove that this works. So what we're going to do is we're going to have our legs. Now remember, legs are connected by that right angle, so we have 9.6 squared plus 6.4 squared equals 16 squared. And if you need a refresher on the Pythagorean theorem, it's a squared plus b squared equals c squared. C being our hypotenuse. Alright, so then from here we're going to solve and see and make sure if they equal each other. Okay? So 9.6 squared is 92.16. 6.4 squared is 40.96. And then 16 squared is 256. Now I'm going to simplify the 92 and the 40. So 92.16 plus 40.96 is going to be 133.12. It's equal to 256. Well, that is not correct. So I can automatically say, well, 9.6 slash AY, I'm sorry, XY is not a tangent line. So this is not true. Okay, so let's do number 2. So number 2, it's the same idea. So let's just identify where our 90-degree angle is. So our 90-degree angle is right here, connecting that line of tangency and the radius. And now we're going to use our Pythagorean theorem. So a squared plus b squared equals c squared. C being our hypotenuse. Well, remember a and b are legs connected by that right angle. So a squared plus 10 squared equals 5 squared. But you're probably thinking, wait, Miss Smith, that 5 looks very particularly placed. And you're right. So this is not 5 squared. If you notice, the 5 is only going to have to do with this single part right here. And we still need to find this single part. Well, we have the center to the outside of, or the center to the edge of the circle. So what is that? That's the radius. And we know what the radius is. It's 8. So we're going to do 8 plus 5, which is 14. So instead of 5, we're going to put 14 squared here. Okay? So now let's just go through and solve for these squareds. So we have 8 squared, which is 64, plus 10 squared, which is 100, and then 14 squared is 196. Add those two legs together and we get 164 equals 196. So close, but so far, this does not work. So this is not true. Alright. So now we're going to move on to questions where, well, what would we have to make the tangent in order to be tangent? So let's look at this first one over here. We have x for one side, 7.1 for the radius, and then we have 18 for that guy. Well, the first thing that we need to do is identify where our right angle is, because we know that tangents are perpendicular to the radius. So this is our tangent. And please note that it says assume tangents that appear to be tangent are tangent. Alright, so we identified our angle, and let's see if we have any missing information. Well, I noticed that the 7.1 is only applied right here, and that's the radius. Well, we need to also apply it to this side, so this is also 7.1, so the entire side is 14.2. Alright, so let's set up our Pythagorean theorem. So a squared and b squared, remember those are the legs that are connected by the right angle. So we have x squared plus 14.2 squared is equal to 18 squared. Alright, so let's simplify those squareds. So bringing down x squared, we have 14.2 squared, which is going to be 201.64. 18 squared is going to be 324. So now we got to solve for x. So we're going to subtract the 201. So now we have x squared equals 122.36. And then solve for x by taking the square root of both sides. And the square root of 122.36 is 11.06. And we would never take the negative version of this because we can't have a negative length side. So we're going to have x stay as the positive 11.06. Alright, so let's move on to the next one. So this one looks a little bit different, you're probably thinking. And they're both tangents. They both connect at the point outside a circle. So if you remember from the beginning, this is two tangent theorems, so they're congruent to each other. So we can set them equal to each other. So we have 2x plus 16 equals 7x minus 29. And now all we have to do is solve for x, and that will be our answer. So I want you to pause right here and solve for x. Alright, so if you did this correctly, you should have gotten x to be 5. And now we could solve to find the lengths of each of those sides, if that were the question being asked. Alright, now, so that's tangents, so let's move on to chords. Alright? Alright, so a chord is going to be a segment that joins 2 points in a circle. So say we had A, B, C, and D. Well, really, a chord is just connecting these 2 points. So that's a chord, this is a chord, this is a chord. You know, I could go on. I can make any chord that I wanted. So, you know, it's just connecting 2 points in a circle. So now let's use this in some problems. So for this first problem, we have a line, a diameter, and we have a chord, and then a small segment here. So we need to solve for x. Now, if we look at this, I do notice that we have a right angle right there, and that tells me, well, isn't that just being bisected? Isn't the chord just being bisected? And that's true. That's one of our theorems. Is that if we have a radius with a 90-degree angle and against the chord, that means we are going to have these two segments are equal to each other. It's being divided in half. So we can just say x equals 6 by this theorem. Alright, so let's move on. Alright, so we have something kind of very different from the first one. So if measure of arc JK equals 7x minus 39 and measure of arc ML equals 87 degrees, find x. Well, we have our circle here and it says that JK is congruent to ML. And a property of chords is that if the chords are congruent, then we have the arcs are congruent as well. So this arc is congruent to this arc. So all I have to do for this one is set 7x minus 39 equal to 87. And then we can solve for x. So I want you to pause your video here and solve for x. So if you did this correctly, you should have gotten x equal 18. Again, you're just setting those arcs equal to each other and solving for x, and x will be 18. Alright, let's move on. So here we have, if the measure of arc LM equals 8x minus 56, so arc LM is here, and arc NP equals 5x plus 22, we want to find LP. So if you notice, LP is this small measurement here. So this requires a little bit of multiple steps. So how are we going to find x? Well, we're going to use the information given in the circle. So if you notice, very small marks are on these little segments. Well, if those segments are an equal distance away from those chords, then we can automatically say, well, the chords are equal or congruent to each other as well. So if we have congruent chords, as I've been saying, then the arcs are congruent. So we can say 8x minus 56 equals 5x plus 22. So now let's solve for x. So subtracting 5x from both sides, so I have 3x, and then adding 56 to both sides, and I have 78, and then dividing 78 by 3, I get 26. So now I know what x equals. So now I need to find the measures of NP and ML. So pause the video here. I want you to find both of those arc measures. So plug in x and find both of those measures. So you should have gotten 152 for your arcs. So now our last part is to solve for LP. And we can do that by adding all of our angles together to get 360. So you have 152, and it's just multiplied by 2, plus 39, plus x, which is our unknown arc, equals 360. So now what I want you to do is find that missing measurement. So you would have added all of this and then subtracted it from 360, and you get the measure of LP, that arc, to be 17. And that's how you do that. That's it for today. Have an awesome day, guys.